As those of my fellow seekers who follow my community postings are aware, my source of information, my backup brain as it were, the British Library, is currently being subjected to a ransomware attack. And so I have resurrected the topic that I first conceived during the darkest days of COVID, the 10-parsec map. Created in 2021 by a team of European astronomers from Gaia data, the map is the most accurate attempt to plot the various stars and substellar objects within 10 parsecs of the Sun on a two-dimensional surface, combining such information as size, color, and any extrasolar planets. This series is essentially myself, with the help of an artist, traveling to each of these locations in turn, and revealing what I can of their histories, geographies, and quirks. To date, I have covered every star within a cylindrical section of the map 4 parsecs in radius, and am in the process of beginning the 3rd, 5th to 6th parsec range. But 2 years is a long time in astronomy, and much can change. So before I go on, I must address those discoveries that, in the 2 years since I last took the helm, have affected those stars I have already visited. Lalande 21185. When I last left Lalande 21185, a somewhat typical red dwarf about 8 light-years from the Sun, it had one planet, detected in 2020 by the elder workhorse of exoplanet studies, the radial velocity method. The planet is about 2.5 times the mass of the Earth, and possesses a 12-day orbit. But in 2021, astronomers using France's SOPHY spectrograph identified a second, roughly Neptune-sized planet in a nearly 8-year orbit around Lalande, far beyond the star's habitable zone. Gliese 1002. When I first visited Gliese 1002, a smallish red dwarf about the size of Proxima Centauri and 16 light-years from the Sun, I had little to say about it. In fact, when timestamping the video, I simply lumped it in under some red dwarfs. But in the intervening 2 years, Gliese 1002 has become far more interesting. In December 2022, a team at the Astrophysical Institute of the Canaries, employing both the European Southern Observatory's ESPRESSO and the Calor Alto Observatory's Carmine spectrographs, detected the presence of 2 planets in orbit around Gliese 1002, each just slightly larger than the Earth, and with orbital periods of 10 and 21 days respectively. Mouth-wateringly, these orbits potentially place these 2 worlds in their star's habitable zone. The innermost planet, B, would, assuming an Earth-like atmosphere, have an average temperature of 1 Celsius, but would rise to Earth-like temperatures with twice the greenhouse gases. The outer planet can only be considered habitable with a certain degree of optimism. Without additional greenhouse gases, it would have an average surface temperature comparable to Mars. If the greenhouse gases in the atmosphere were octupled, however, its surface would reach Earth-like temperatures, albeit at a CO2 mixture that would prove toxic to us over long periods. At 22 light-years from the Sun, we find the triple red dwarf system LTT 1445. LTT 1445 was already a fairly interesting destination, with one confirmed planet, a super-Earth of 2.73 Earth masses, which orbits the largest of the trio, A, in just 5 days, the closest planet to the Sun known to transit its star. But in 2021 and 2022, 2 new planets were also found in orbit around A, both via radial velocity. The first, C, is closer to LTT than B, with an orbital period of 3 days, and a mass roughly equal to Earth, while the second, D, has a mass almost identical to B and an orbital period of 24.5 days. C is beyond salvation, with an equilibrium temperature similar to Mercury, and B only slightly less so. D, on the other hand, has an equilibrium temperature, assuming Earth-like conditions, of 73 Celsius. Not a paradise, perhaps, but a potential home for the toughest forms of life. Finally, at 25 light-years from the Sun, we find Gliese 514. Other than describing it as a large red dwarf about half the size of the Sun, I basically skipped this one in the first go-around. But in 2022, an archive search of 25 years of radial velocity data unearthed a 5-Earth mass planet in orbit around Gliese 514, with a 140-day orbit around its feeble star, an orbit that would, assuming an Earth-like atmosphere, grant it an average surface temperature of 0 Celsius. Doubling the greenhouse effect would, however, give it an Earth-like surface temperature. Like Vega, Gliese 514 has an infrared excess, suggesting it also possesses a debris disk. And that's the travel news for your previous destinations. Please join me on my outward journey into the unknown when it premieres on YouTube on Tuesday, the 28th of November.